Hi everyone, pupils, how are you today? I hope everyone is in good health. I am Yolai Bo from Sekolah Menengah Kebangsaan Bandar Baru Sentul, Kuala Lumpur. Are you ready to learn more about science today? Great, let's begin. Today, we are going to learn about the flow of electrical current. You have already learned about energy and electric current. Now, you will know the difference between the flow of electrical current in the series circuit and in the parallel circuit. Before we get started, let us take a look at the learning objectives for our lesson today. There are 4 objectives. First, you will elaborate and communicate about the flow of electric current in the series circuit and parallel circuit. Second, you will be able to characterize current, voltage, and resistance and their units. Third, you will be able to draw a conclusion on the relationship between current, voltage, and resistance. Boys and girls, can you explain why at the beginning both bulbs light up? But when one bulb is broken, the other bulb does not light up. Yes, that is an excellent answer. It is because the bulbs are connected in a series circuit. What happens if both bulbs are connected in a parallel circuit? Can the other bulbs light up when one bulb is broken? You are right. In a parallel circuit, every electrical appliance can be switched on or off individually. That's why the bulb still can light up when one bulb is broken. This information is related to the topic that we are going to learn today. Before we study the type of electric circuit, we must know the electrical components. We know that the electric current requires a complete path which enables it to flow. This path is known as an electric circuit. A complete electric circuit is made up of various electrical components which are represented by symbols. These symbols are used to draw circuit diagrams.
Electricity causes muscle cells in your heart to contract, essentially making it beat. Electrocardiogram (ECG) machines measure the electricity going through the heart. As the heart beats in a healthy person, the ECG machines displays a line moving across the screen with regular spikes. Echidnas and platypuses use the electrical impulses emitted by their prey to find food. A platypus' bill is covered in nearly 40,000 electricity sensors or electroreceptors arranged in a series of stripes. The word electrocute is a combination of the words electro and execute, meaning you were killed by electricity. So, if you don't die, you were not electrocuted, only shocked. In Albertville, France, host city of the 1992 Winter Olympics, They make electricity from cheese. Since whey isn't needed to make Beaufort cheese, bacteria is added to the whey, turning it into biogas. This gas is then fed through an engine which heats water to generate electricity.
Pupils, let us identify the symbol, figure, and function of a few common electrical components. This is called a switch. This is a dry cell. This is a voltmeter. This is an ammeter. This is a bulb. This is a resistor. And the last electrical component is the fuse. Now, we must use the various electrical components to make a complete circuit. These components are represented by symbols. These symbols are used to draw a circuit diagram. Do you know the difference between a closed circuit and an open circuit? Let's find out. A closed circuit is when the switch is closed and there is no gap in the circuit. In the closed circuit, the electric current can flow from one end of the dry cell to the other end, and the bulb will light up. On the other hand, an open circuit is when the switch is open. Therefore, there is a gap in the circuit. In the open circuit, the electric current cannot flow in the circuit and the bulb will not light up. Now, boys and girls, let us look at this picture. What is the difference between these two diagrams? Yes, you are absolutely right. The arrangement of the bulbs is different. Diagram 1 shows the series circuit, while diagram 2 shows the parallel circuit. For your information, the electrical components in the series circuit are connected along a single electrical path, and each component has the same current through it, which is equal to the current through the network. The voltage across the network is equal to the sum of the voltage across each component. To calculate the total effective resistance of a number of resistors connected in a series circuit, you need to add up the individual resistances. This is done by using the following formula. R is equal to R1 plus R2 and so on. What are the advantages and disadvantages of the series circuit? The first advantage is every component in the circuit receives the same amount of current. Second, every component is controlled by the same switch. Third, an increase in voltage will supply more electric current. There are also 3 disadvantages of using the series circuit. First, when one of the electrical appliances is damaged, other electrical appliances in the circuit cease to function. Second, adding more electrical appliances increases resistance and decreases the flow of the current. And third, each electrical appliance cannot be switched off individually. Now, let us learn about the parallel circuit. Boys and girls, in a parallel circuit, the electrical components are connected along multiple paths, and each component has the same voltage across it, equal to the voltage across the network. The current through the network is equal to the sum of the currents through each component. To calculate the total effective resistance of two resistors connected in a parallel circuit, you can use the following formula. 1 over R is equal to 1 over R1 plus 1 over R2. Now, let us figure out the advantages and disadvantages of the parallel circuit. The first advantage is every electrical appliance can be switched on or off separately. The second advantage is that the increase in the number of electrical appliances does not affect the function of other appliances in the same circuit. While the disadvantage is the voltage for every electrical appliance cannot be adjusted because the voltage is the same as the source of the voltage. That's why our electrical wiring system in our homes is connected in a parallel circuit. All the lights at home are connected in the parallel circuit to ensure that every light gets the same voltage from the main power supply. The current that flows from the main power supply to the circuit is controlled by a distribution panel.
Electricity first made its appearance in Malaysia at the turn of the 20th century, and the earliest record of power generation can be traced back to a small mining town in Rawang, Selangor. Two enterprising individuals, Lokyu and Tambusami Pillai, installed an electric generator in 1894 to operate their mines. They were the first to use electric pumps for mining in Malaya and marked the great beginning of the story of electricity in Malaysia. In the same year, private supply for street lighting purposes was extended to Rawang town, and in 1895, the railway stations in Kuala Lumpur received its first electricity supply. In 1900, the Sempam Hydroelectric Power Station in Raub, built by the Raub Australian Gold Mining Company, became the first power station in Malaysia. Malaysia is the second largest oil and natural gas producer in Southeast Asia and is the fifth largest exporter of liquefied natural gas (LNG) in the world as of 2019. It is strategically located on important routes for seaborne energy trade. According to the Oil and Gas Journal (OGJ), Malaysia held proved oil reserve of 3.6 billion barrels as of January 2020, the fourth largest reserves in Asia Pacific after China, India, and Vietnam. Nearly all of Malaysia's oil comes from offshore fields. The vast share of Malaysia's power comes from thermal power plants. That is, power generated from fuel sources like coal, fuel, gas, and bio oil.
Now, pupils, let us solve a numerical problem related to current, voltage, and resistance in the series circuit by looking at the example given. Two resistors, R1 and R2, are connected in series in a circuit as shown in the figure. Calculate the current I in the circuit. Can you name the formula we are going to use in order to solve the problem? Yes, that is correct. To solve this problem, we must use Ohm's law. Current is equal to voltage over resistance. So, 6 volt of voltage is divided by 4 ohm of resistance is equal to 1.5 ampere of current.
Ever wondered how fast electricity travels? The answer is the speed of light. It has been proven that electricity travels at the same speed as light, which totals an astonishing 670,616,629 miles per hour. To break this down further, 670,616,629 miles per hour equals 300 million meters per second. A lightning bolt can get really hot and reach temperatures of 30,000 degrees Celsius or 54,000 Fahrenheit. Lightning is caused by the discharge of electricity in the atmosphere. Lightning is, in fact, caused by one huge electric current. While the clouds may seem to be peacefully moving across the sky, they are actually deceptively active. With ever-changing weather conditions, water and ice are forced up into the atmosphere by warm air currents and then forced back down by gravity. During their travels, the pair become compressed in the clouds, circulating not only around but also inside. Over time, an electric charge starts to build up inside the clouds, similar to where you rub a balloon against a surface to create static electricity. Inside the clouds, there are now positive electric charges building up at the top and negative resting along the bottom. These then try their hardest to reach each other in an attempt to neutralize. On a normal day, this isn't a problem. However, on a stormy day, the turbulent winds cause the electric charges to separate. The negative charges start moving towards the ground, known to scientists as a stepped leader. In the meantime, an upward leader forms on the earth below, pushing positive charges up into the air. When these meet, they create a giant electric current, which shoots up into the cloud. This is known as lightning.
Next, pupils, let us solve another numerical problem involving current, voltage, and resistance in the parallel circuit by looking at the example shown here. Two resistors, R1 and R2, are connected in parallel in a circuit. Calculate the effective resistance R. To solve this problem, we must use the specific formula to calculate effective resistance in a parallel circuit. 1 over capital R is equal to 1 over 2 ohm plus 1 over 2 ohm. Now, that we know, 1 over capital R is equal to 1 ohm. Therefore, the effective resistance in the parallel circuit is equal to 1 ohm. Pupils, it looks like we have come to the quiz section of our lesson today. Are you ready for the first question? First question. Boys and girls, what is the electrical component for this symbol? Excellent! You are correct. It is a fuse. Question 2. Look at the figure. Two resistors, R1 and R2, are connected in series. In a circuit, find the effective resistance, R. Very good. The answer is 4 ohm. To calculate the total overall resistance of a number of resistors connected in a series circuit, you must add up the individual resistances. Let us move on to the next question. Find the value of the current I. Excellent! By using the Ohm's law formula, substitute the value of V with 6 volt and R with 4 ohm. The answer will be 1.5 ampere. Here is another question to answer. Find the voltage value for V1 and V2. The value of V1 and V2 is the same. We must use Ohm's law to find the value of V1 and V2. The value of the current I in the diagram is 1.5 ampere. Well, pupils, looks like we have come to the end of our lesson. Let us recall what we have learned today. By now, pupils, you should be able to elaborate and communicate about the flow of electric current in series circuits and parallel circuits. You also can characterize current, voltage, and resistance and their units. Lastly, you can draw a conclusion on the relationship between current, voltage, and resistance. Well, that's all for today. I hope you enjoyed today's lesson. Boys and girls, please use the knowledge you have gained today in your daily life. Until we meet again, stay safe, everyone. Goodbye.